Cool. Sorry, everybody. I'm here. I'm just trying to wrap some stuff up here. All right. Hey, everybody. Ian here. Just doing some more C++ coding for a project I'm working on. It's just a personal project. Yeah. So just a quick disclaimer. I am not a very good C++ developer. So I'm kind of learning as I go along here. Just putting that out there. And I'm going to try and put together a new. I'm basically starting from scratch with this API project, building on top of a basically a multi-threading queue library. So in essence, basically just to handle high concurrency, basically lots of requests, lots of tasks, saturating the CPU all at once. And then with minimal memory, just kind of managing hundreds of thousands potentially of pending things that need to be processed. So that library is complete. I worked on that over the course of, I don't know, 2-3 weeks maybe. More like 2 weeks. So that I think is pretty well wrapped up. It's looking good. No memory leaks that I could detect using, I think it's called address sanitizer. With the basically a tool with C++ builds to kind of like add some extra binary information to kind of monitor memory address usage. And what's cool about it is it will watch what's going on while you run a test against your code. You do a bunch of work, let it run for a while, keep hitting it, keep doing things, and then you just kind of monitor it and see if your memory. Well, you can watch the process on your machine and just watch the memory usage. But this basically looks deeper and gives you detailed information about what appears to be leaked and where is the call site for your code where that leak happened, and then you can kind of go in and try to speculate, looking at the code, just determine, am I handling this returned object? Is it being destroyed when it's done being used? Is it handled automatically or not, and stuff like that. So that's pretty well wrapped up. And so today what I'm going to be doing is just basically kind of what I'm going to do is I'm going to start building out kind of the business layer of my API. So it'll be kind of like a reusable business logic library for running on the server. So it'll take requests like get user or get some object from the database, and then return that, right? So it's pretty simple, pretty straightforward. I think the more interesting parts will just be kind of putting the pieces together of just like how to get the libraries, basically how to import that into this project, use the task queuing library so that it gives me the support I need for using C++ coroutines. And then from there, basically just kind of, I think what I'll do is start on the data layer. So I'll just start building maybe a data service, and then from there kind of try to call that data service maybe with a test, and basically just have it store information, retrieve it, that type of thing. Okay, so right now what I'm doing is I'm pulling up in a separate window here. I'm just kind of pulling up my generated class files to represent my database entities. And then what I'm going to do is I'm going to see how I can kind of, let's see if they even work. I have not tested these yet, so give me just a second. Okay. Actually, let's just go ahead and build out the folders for the project here. And I just learned kind of a cool trick with make directory. But basically what you can do is you can just, you can do, I didn't know this, but you can do like nested folders with it. So, for example, I want to create a source folder. And then I want to create some nested folders inside of the source folder. So I can just do basically a open squiggly, and then some nested folders inside of that. These are for later. This is going to be for the kind of the HTTP and gRPC handlers for the API that will call into my services. Okay, so yeah, so anyways, so HTTP, gRPC, and then that will be those nested folders inside of transport. And let's see here, inside of transport I want to create, wait, no, I'm sorry, at the top layer I want to create, oh no, this is going in, I'm sorry, this is going under service, I mean under source. Let's see, service, repository, yeah, I think I'm going to actually change this to sorry about that. Typing in other windows here. Okay, so let's go ahead and let's see. For now, I'll just go ahead and create those folders. But all right, so we closed it off, so that's all the folders. Boom. Then we go to the project. We should be able to see those: source, domain, repository, service, transport. Let me pull up some other windows. Yeah, so I'm going to rename this one to data, and then what I'll do All right. This is tricky. Okay, so I'm gonna try and generate a CMake list file to basically just put a basically just pull in these projects externally. Can't fix my mouse. The scroll is kind of screwed up right now. Alright, so I'm going to create a new file here. I guess there's no... Oh, here it is. I was trying to figure out what's going on there. Add to get... I don't know why it's not configured. What? Select make list? Yeah. No, I want to... Okay, just load it, I guess. This thing's so dumb. Okay, so it's just doing a bunch of detecting my local C compiler. Alright, cool. Okay, let's just go ahead and type this out. We'll see how this works. Let's see. So let me actually open up another project because I thought I had a different version of I thought I had a different version. Okay, let's see here. Let's see, 3.28. All right, we'll do that. For now, it's just going to be it's just going to be a kind of a generic name. Oh, Okay, wrong spelling on the directive is underscore there. Okay. I don't know how this got to be spaced here. I cannot for the life of me type with all these suggestions it's giving me. Okay. I'm just going to copy paste this part in from the example I've got. There's really nothing though in here. Okay, so alright, so we're finally okay, so we got our sources which don't exist yet, and then we've got now we want to add an executable. So this is basically telling it what to output for the actual final binary that we can execute from the command line. Did I do the right syntax? No, I did not. I thought that looked weird. Okay, there we go. Alright, so we're basically just going to, the executable is going to be based off of these sources and the project name. And I don't think, am I blind? Why is this red? Expected some kind of, is that just a, oh, okay, that was just a, yeah, it was missing an underscore there. Okay. Alright, target include directories. For project name. And then private because we're not it's not meant to be exposed to consumers. I mean, I should say its dependencies are not exposed to consumers. Okay. Okay, so current source directory, so that's our project root, and then the source folder. I'm not entirely sure what this is doing here. Okay, so apparently these are special compiler options. I don't know. I'll have to look into this later. I'm not sure what these are actually, what these compiler options are specifically trying to do here or accomplish. Very odd syntax. Indif with an open close. Yeah, it's just weird. I don't know how they're using this. Maybe it's macros or something. That's my assumption. Okay. So we got that going. I kind of want to, let me see here. I want to figure out how to bring in my other dependencies from other projects. Part of me thinks that there should be a way to do that. I guess you can use a fetch content directive, or I suppose they're macros, I don't know. Okay, it looks like there is a way to do that. Let me see what wait a second, what's going on here? Did I type this? So apparently I can do, I'm not sure if I can add include at the top, include fetch content. And then somewhere, oh wait, this is the wrong, sorry, wrong project. I don't want to change that. Maybe somewhere after sources, call fetch content, and then declare it, give it some kind of a name. Lib async orchestrator. I think that's the name. Lib async orchestrator. Yeah. Okay. And then I guess I can do so I guess this is how I'll do like a relative path, so going back one from the main source directory back to my other project on my hard drive. And then what I'll do is I'll try to, let's see, so now I guess I have to make it available. So I guess I'm okay, declare it, then make it available. Okay, I'm just gonna copy paste this. Okay. Target link libraries. So now I have to link it. And I guess you could do for the current project. Private. Okay, so I want to basically link this guy to my project. Okay. One caveat. Oh, okay. So this is the target for the basically the library, and I want to make sure that in the target include no, sorry, am I in the right thing here? Target link libraries. I want to actually define or specify the basically the output, the library name, which that's not right. That's the wrong one. I meant to do this one. So I would imagine that that's actually the reason for that is because the build, probably going to output, let's see, it's probably going to output this as the actual name. I don't know. I mean, according to AI here, it says that the fetch content declared name is just for CMake's internal tracking. What matters for linking is the target name from the libraries, add library call. So basically this part right here. However, I just don't know where it's yeah, I don't see that file anywhere. I don't see it like a library file for async orchestrator. Maybe it's because the build folder is not the right place to look. Maybe I need to build it. But for now, I'm gonna let this project manage the build. Okay, so what I want to do now is add another project that I built. I'm actually gonna probably have to open it. Let's see here. Oh, this project actually depends on interesting. Yeah, I don't know if that's how I want to, like, if I've got yeah, I'm not sure if I want. So the problem is that my both projects basically both let's see, this also is going to depend on this kind of async orchestrator and for its coroutines, but the Postgres library also depends on the async orchestrator. So the question is, do I need to combine these in some way, or make the async orchestrator some sort of reusable, linkable library that can be consumed by both? Let's see here. Let's ask AI real quick. So I have this project. I have this other one. Yeah, so this cpp lib Postgres SQL depends on and they should share the same task queues. Do I need to I need like a reusable binary for or linkable library for these projects, so they can use the same. I want them to use the same task queues in the event loops. I don't want them to go off and like create their own instances of these event loops and use up more threads basically. Yeah, this will be interesting to see what it has to say. I'm not sure. I'm really not sure. Okay, so the suggestion is, oh, that makes sense. This actually makes a lot of sense. I should have known better. So the recommended approach is to basically, for my Postgres lit library to project, to basically accept the async orchestrator as a dependency, or the basically, yeah, in essence, that application should be passed as a dependency. How best to do that? That's the question. So let me open up another instance here of wait, what? What's going on here? Oh, my bad. So yeah, so I'll show you here. Sorry about that. So here's the suggestion. So the Postgres client explicitly accepts this kind of async orchestrator task queue. Yeah, let's just go ahead and let it look at the other project and see what it kind of comes up with here. That should be a valid project folder. What's going on here? Let's see. Oh, found it. Hyphen, not an underscore. I think that was my challenge earlier. I gotta fix my project names. All right, I'm just gonna let this. Just let it read all the files. I'm trying to think. So I think the main thing is the scheduler. And it needs, I think it needs an instance returned from the scheduler. The scheduler needs to return some kind of an instance. So that way when the application starts, you fire up the scheduler, choose your number of like worker threads, and then let it basically just go from there. Let it give you like a handle or an instance to that class, and then you can kind of pass that around. Let me go back to, let's see here. I'm Trying to figure out which project I want to go to. My brain just like shuts off as soon as I start streaming, I swear. Is my camera still working? No, it's broken. Perfect time for a restroom break. Be right back. Alright, sorry about that. Okay. What happened? I feel like I'm missing a window here. Oh, I was going to go through this code really quick. Okay. So, oh, sorry, that's kind of loud. So there's a bunch of, basically there's like a bunch of, so inside this project, there's a bunch of supporting types, awaitables, I guess, is how you refer to them. Sorry, over here in task. Which weirdly, I don't see where task is in this project. What's going on? Oh, it's in the includes. Okay, my bad. I forgot how I organized it. Maybe AI did that and I just forgot. Okay, so basically you got all these awaitables, and the compiler depends on these awaitables for basically to be able to handle the coroutine syntax. So if you look at like one of these tests, maybe, you know, like you got a co-return. Sorry for the jumpiness. My mouse is kind of screwed up right now. Yeah, let me just, oops. Good grief. It's really hard to type when my mic is like in my face. Okay. So like for example, here's one. Okay, so basically sleep for example, this is a, okay, see, this returns a sleep awaitable, and that supporting sleep awaitable struct is providing for the compiler like the basically the methods for it to call to determine the various stages of of this awaitable. There's also other awaitables that I forget what this one's used for, but this one's a I think this one is going to be for like IO tasks where it like calls the where it's basically dependent on a file descriptor in the in the OS. So like if there's like some socket connection to, you know, the database and it's waiting for the stream to be ready or done, and so it registers file descriptor, and then it ties it to this, basically gives it this handle to a coroutine, and then somehow once done, yeah, this one's, I think this one's actually more of like a, I'm trying to find an example of an actual, let me find a, okay, IO duration, that's not a good one, sorry. Well, anyway, I don't know. So basically, here's a sleep awaitable, and then not right now, buddy. Not right now. No. Hey, leave them. Leave them. My dog is just like going crazy. All right, that's enough. Outside. 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 Get outside. All right, that's enough. All right. All right, sorry about that. Sleep waitable, basically take the handle, add it to the timer queue, and then the event loop will process it. And basically the timer queue will handle the like watching the time. When that time comes up, it'll basically just resume this. Yeah, basically just resume the handle. It'll basically process, take the handle, add it to, let's see, timer, create a timer entry, whatever that is, and then that will be, let's see, okay. Okay, so it's got a Boolean operator. So it basically just compares timer entries. And I think this this type here, this Boolean operator, is so that it'll automatically order. It'll order it inside of this queue. Okay, yeah, sift up, I think is will basically, it'll use the what am I trying to say? It'll basically use the not sift up. I don't know if it's sift up, but basically this heap probably is a vector of timer entry. How does it? I guess sift up automatically is going to iterate. Okay, yeah. So it'll basically, that's kind of weird. That could be a constant. It'll basically just iterate over the heap, and then it'll basically just compare deadlines. I thought that was built in though. That's what's confusing to me. I thought that was why you had to have, I don't know. I don't know why that has its own custom operator, because it looks like it's just doing it manually here in the sift up method. So it adds it to the timer's queue. Timer's queue gets processed, and inside of it there is a timer entry, and then it's basically going to say this operator might actually be for checking to see if its time has expired, maybe. But basically it's going to process that, and then when it's done it's going to basically automatically wake up. So these awaitables are just support for generating all this compiler. The compiler will take this and convert this into a bunch of into a promise, and it'll execute the methods on the awaitable. It'll execute these methods in line, and then it'll actually and then this kind of basically controls the kind of the time span of these awaitables. Now if I shrink this down, there's some other ones in here. So there's yield awaitable, FD awaitable. Okay. And then I guess with that promise, what you get is you get you get a task, and then the task basically has a bunch of it's kind of like another layer on top of that. So it turns everything inside this method, because of this return type. It'll turn, the compiler knows that, to turn this into basically into an awaitable. This whole thing becomes a promise basically. Yeah, so it's kind of weird. It's really confusing, because the compiler does a lot of stuff implicitly behind the scenes. Generates a bunch of code, and then you just kind of have to maybe there's some documentation on it. I haven't actually looked at that. I kind of poked around at AI, asking it questions a lot, and that was how I kind of learned kind of the inner workings of what it's doing. Back to our progress here. Okay, it wants to read that file. I thought I was trying to create it. Yeah, AI is kind of dumb. It just doesn't really know. And it's a pretty small project. I expect it to sort of be a little faster, but it is what it is. Anyway, if I go back to my scheduler, if you instantiate it, you get you set the number. Well, currently it just defaults to all your threads. Basically, is your thread count for your current system. And then it instantiates a bunch of workers. I don't know where the actual event loop is being defined. I think that's defined at the worker level. We'll see if AI's figured that out yet. Okay, so option 1, pass the scheduler to the connection pool. Option 2, use the current and just spawn local for child tasks already available. I think it actually just awaits yeah, it just awaits like connections. It doesn't oh, okay, I see the difference. Yeah, it's not actually using the scheduler to spawn the task. Waits the result before continuing. The coroutine chain stays on the same worker thread using that thread's event loop. Okay, got it. Okay, so the architecture is correct. According to AI, I'm just reading what it says. So basically spawn, if I could keep my mouse from rolling like that, that is so annoying. So it spawns, let's see, so spawn an anonymous kind of method. Initialize the pool. Okay, I see. Okay, so lib postgres SQL already declares async orchestrator via fetch content from get_t to override with local paths. Declare it first in your cmake list fetch content. Uses first declaration wins. Okay. Async orchestrator declared first, local path wins over get_t. Okay, and then both projects share the same target, single binary. Link to which publicly links to I'm just gonna have it make those changes. I don't really feel like messing with it right now. What was that called? Business services? I hate cmake list files, honestly. They're just very, very confusing. It's almost like too much abstraction from just how it works. So I guess I don't need to include at the top. I can just include before I use the fetch. Fetch declare async orchestrator. Fetch declare, then get this other project. Okay. And then to link those, did I include this? Yeah, build examples off. Okay, that's the flag to not build that. Okay, so I have to make those available. Let's see here, add executable, project name, sources. I'm going to move this up so I can see what I'm doing here. Let's see, so I want to do that. Alright, let's see how this works here. Okay, so we're going to create a main.cpp file to start our application. Why do I have two, what's going on here? Oh. Whoops. This file does not belong to any. Yes, it does. It does belong. Maybe I need to reload CMake for this. I have no idea what that's trying to do. Okay, so it included it twice. That's cool. It should be part of sources. I shouldn't have to. Sources is declared here. What gives? What gives? Oh wait, you know what? Probably getting an error and I didn't even notice. My bad. Okay, so there is an error. Line 1. CMake minimum. Did I type? Yeah, that's wrong. Unknown argument. Wait, what is going on here? CMake. Oh, you gotta put version. Okay. What did that just do? Wow, there's all kinds of stuff in here now. Okay, so it fetched. It fetched all this stuff in, but it looks like it's kind of linked, maybe. Maybe not. Hopefully it's just linked, or like symbols, basically. Okay, so that's all there, and then so according to Claude, I need to include a few things. So I need to include my library, namespace, I should say, and then it's just gray because it's not used. Let's try this instead. Let's just type the code and then let it suggest. Okay, this is going to return a task. Connection pool, reference. Okay, it's already trying to suggest something. Include. Cool, so that cleared that up. It's never used, okay, obviously. And then we're gonna wait. We're gonna call pool.acquire. No, sorry, wrong one. Initialize. Okay, now we want to acquire. All right, let's see here. All right, so we got a connection and we're going to try to query something. I'm sorry, that's not what I want to do. I want to select version. Oh, thanks. That's hot. Oh. I just spilt tea all over my shirt. All right. Cool deal. All right, so that's probably, I assume that's Postgres, or that might be, who knows, that might be part of the standard SQL definition. Anyways, get the version of the database. Nice. Can't even type result. Okay, so we want to check, is it okay? And make sure we got a row count. That makes sense. Maybe what we can do is just do like a standard cout. And then, oh, gotta include that too. I don't know why. Should I keep those separate? Might be cleaner. All right, let's see what AI suggests here. Output the database version. Is inline actually the proper way to I think that's correct, but okay, so you can use a we can use an inline here. It's not like in a loop or anything, but Yeah, what is this result type? Let's see, it's query result. I want to get the actual data, so get. I guess you gotta call get. I gotta go through this library and fix it. Alright, so let's just do get. Alright, cool. Fix that. Okay, and then... Okay, so our method is going to... It's going to be a... it's basically going to be a coroutine. It's going to be basically an async task. And then it's going to try and get a connection, get it from the database. This probably needs to be a const, because we're not... we're not actually mutating it in any way. Okay. So that prints. I don't know if that's necessary, but I decided to print because I like to see things happening. We'll add a main function for the input, the entry point for our application. Let's see here. Create a scheduler. Yeah, finally get to use this darn thing. Been working on it for weeks. Okay, let's go ahead and just import that. I'm using a hotkey, Alt Enter, and it just so it added async orc / scheduler.h. I have a lot to learn about C++, so I guess what that's saying is like going to the namespace and then saying, well, no, not the namespace. It's actually looks like a folder path. Maybe that is referencing the namespace though, because I don't know. Let me double check actually. Now I'm curious. If I go to my libasync project, it is a folder, but is it the folder or is it the namespace? Anyway, I suspect it's a folder because it's referencing the header file, the explicit header file name from the linked library that was fetched using CMake. So if we go to our fetch async orchestrator, get it from a local directory, and then make it available, and then target it. I'll have to do some more research on the kind of C++ like linking libraries, and just kind of how that whole mechanism, that whole thing works. Okay, scheduler start. I don't know why that brought this down here. Whatever. So the pool requires a connection string. Let me look what my password is for my dev database. I think that's correct. I think that'll work. I know it's localhost. I know that much. Okay, connection string. What else? What else does pool require? Or pool config, I should say. Okay, so it just defaults to. I don't even have to pass min and max connections, so I'm not even gonna pass those. That should compile and it should run. I'm just fascinated by C++ syntax. I always have been. It's always just mind-blowing how people could read this stuff and write in it just fluently. I see some people kind of get... sorry, so we're going to spawn... What are we doing here? Okay, I was wondering what this run method... I didn't even remember the name. Okay. So we're passing run. We're saying to spawn the run method, which is a task. And we're saying, you know, hey, execute this task, and then that will spawn. Excuse me. So that'll spawn additional child tasks, and then those will execute on the event loop of the scheduler, because we're actually using the scheduler to run it, and then passing our pool so it can grab a connection from it. I'm really excited to test this. This will be very exciting if it works. Scheduler, and then stop. Hopefully, I don't like, you know what? It's not, I don't think this is going, well, let's see. The problem is, I don't think spawn is a blocking function. My concern is it'll spawn these tasks, send them to the event loop, and then it'll call stop before it actually. Well, although stop is, I mean, stop is actually going to wait for the queue to drain and finish. And I think stop is blocking. Okay, so yeah, this should work. Okay, so Alright, yeah, it might not work at all, so we'll see. It might run into a race condition, so it might call spawn stop, and then stop might not see that the, although it does have a yeah, it's gonna release the, when it updates to running, it's gonna release that, release it as true. And then it's gonna wait for them to be ready. So we'll find out. Okay, so let's go ahead and build this from the command line using cmake. I want to watch it as it works here. Okay, so right now there's no build directory, so we'll do cmake b, and then we'll give it the build folder to output to, and then dcmake build type. Is this a flag for this? Okay, I don't know. It must remove or lighten up the binary. So I don't know. Okay, so let's see here. cmake build. Okay, so we want to build the build folder, which is going to output it's basically just going to output a bunch of make files. Eventually it'll show up here. Oh, you know why it's so slow? It's including all the dependencies. That's really slow. Wow. Okay, now I see why people complain about that. This isn't that big of a project. I might have to figure out a way to do this manually. I might have to do some deep research and just kind of figure out how to link in my libraries, like, or pre-build them and then just include like the pre-built binaries and then link them only, not build them. I honestly don't know. I don't know why that takes so long. Okay. I already did cmake, so now what I want to do is run the binary. How come I don't see my folder here? Oh no, I'm in the wrong flipping. I'm in the wrong folder. How did I get into this folder? That's just bizarre. What else? I want to go to. Okay, so let's try it again. I apologize. Let's just hand type it. Good practice. See, cmake b, and then we want to create the build folder, and then we want to set the dcmake build type to release. There it is. Now I can see the folder. Okay. Okay, cmake build the build folder. Oh, and we got warnings. Are these just warnings or are these actual issues? What is it? What is it saying? In member function, push, warning, suggest parentheses around the plus operand of and. Okay, that's okay. It doesn't need the parentheses. Just I think that's just a warning. Okay, although I might tell it to ignore that or fix it later. Okay, so now we should have a binary in here. There it is. There's our CPP business services. All right, so we should be able to run this code and see what happens. I'll leave this kind of expanded until I'm done. So let's go ahead. Do I need to pass any options? No. Nothing happened. Yeah, I'm actually going to build it with debug symbols, by the way. Alright, I basically am telling AI to take a look at the code to see if it can see any problems. According to this, one way I can do it, yeah, it does. I don't think the scheduler has like a wait. Oh, I forgot about this. I have a helper method for this exact purpose. Okay, so for now, let's just run spawn pool. Wait, what is this done? I could use a helper method to run a single task that runs synchronously, but I actually prefer to use the scheduler. I want to kind of exercise the scheduler code and make sure it works. Okay. Bear with me here. I'm just trying to kind of read some code samples here and then implement them. This is interesting. So we're going to use an atomic. That's kind of neat. It's a lot cleaner. Okay, so done, and then basically we want to, when complete, we want to do done.store, set it to true, interesting way to do this. Memory order acquired, so we want to make sure that we wait till all writes are done, I think, to done. And if it changes to, until it's basically false, till it's, no, sorry. While it's not true, we want to keep looping. And then it's just going to keep sleeping, I guess, and just waiting. That's crazy. What a way to accomplish that. I'm going to make this 10 millisecond. It's actually just maybe 5. It might be really fast. I don't know. Let's see. Okay, so let's go ahead and let's try rebuilding again. Wait, I forget what the actual commands were. My mouse is just not cooperating. Alright, cmake build folder, and then we want to basically do dc make build type. And then we'll do debug. What's wrong? Did I type that wrong? DC make build type. Am I blind? Let's see. Do I have too many? Oh, I got too many dashes. And then now I can do cmake, and I can type it's build, I think. No, okay, build flag and then build folder. How did they, what was the syntax for that? Just the standard build folder. Okay, that was really fast. Now let's do, what's our binary? It's going to be CPP. There we go. It worked. It connected and it returned the database version information. Gave me everything. It even says on x86_64 PC Linux GNU compiled by GCC. Very cool. Very cool. So that that actually worked. Okay. All right, success. So I guess I can just review this really quick. Okay, so we're creating a task. We're getting a pool, initializing it. That does some initialization magic. Create a connection, I guess. Okay, creates the min connections. So basically, just create some connections. That's cool. It should. I'm just looking at this code because I don't. I don't see proper teardown happening unless I miss something. Okay, this calls a release. So when it goes out of scope, it's going to basically call release. However, it's adding a bunch of min connections, so a small amount of connections to idle. However, when it releases and it goes to, let's see, pool, calls release, passing it the current connection, the active connection. Yeah, so let me make a note. What is this project called? This project is okay, cpp lib postgresql pooled connection release. Should it should it close down the connections in the let's go to the header. Async connection. Okay. Yeah, so it's a vector. It can have multiple yeah, I mean, just because they're idle, just because they're in the idle queue or the idle vector, doesn't mean they don't need to be closed down. And then during app shutdown. So basically, in our resource cleanup, we're checking to see if there's a pool instance, I guess. Let's see, what is this? Yeah. And then we're kind of passing it the current active connection, and we're releasing that, but we're not doing that for the other connection that got added to the idle vector. Let's see here, connection is valid. If it's not valid, then just decrement and return. If it's, what's going on here? So if waiters is not empty, then we add it to idle, get the first waiter, let's see here, schedule the waiter, Yeah, this is interesting. I don't know if I like this. I can look into that later. Yeah, and I noticed that release doesn't even, yeah, it doesn't even close. Yeah, these are all things I'll look into. So there we go. Let's see. I gotta see that again. Sorry. It's cool. Alrighty, I'm gonna drop off. So, yeah, sorry for the slow startup. You get to see the pain of creating CMake list files, building, trying to figure out how to build it, and then link a bunch of random source code from my local hard drive. Link the libraries. So I don't know. I'll have to look into that maybe. I kind of don't like the tooling, but maybe the tooling is actually better. However, I have heard a lot of complaints about it, so I'm kind of a little on the fence about using CMake lists. Although I do like the idea that I kind of define everything and then it kind of just will work. And so if I add like new files, I can just add them to this list here and it'll pick those up and execute or build those. So we'll see. Something to think about. Alright, thanks guys. Have a good one. Oh, sorry. Don't forget to like my videos, subscribe, and if you enjoyed it, thanks.